All right. Now, with that, we're going to be moving right along to our third presentation by the day. I'll hand things over to Ms. Samoya Sandiford-Bazin to introduce our third presenter.
All right, and thank you, Mr. Sanka. So our third presenter before we break for lunch would be Mr. Jameel Fraser from the Habitat for Humanity. Mr. Fraser is a project management professional with 15 years of experience in project and financial management, exposure particularly in the areas of pharmaceuticals and construction. The most recent of those years was spent leading the project team and providing wider support in the design of projects and programs for Habitat for Humanity, Trinidad and Tobago. And that organization is basically with a focus on improving the resilience and transforming the lives of communities through low-income housing construction, capacity building, disaster risk reduction, and community revitalization, to name a few. Let us welcome Mr. Jameel Fraser.
Hey, good morning, everyone. Just confirming you're hearing me and seeing the slides.
Yes, Mr. Fraser, hearing you clearly and seeing your slides.
All right, perfect. So thank you for that, Samora, and thanks to ODPM in general for inviting Habitat. We do take every opportunity to share our knowledge and in hopes of building capacity. So as Samora would have said, this morning we're tasked with delivering a presentation on building back better as it relates to home construction, resilient home construction. And this presentation will kind of entail a bit of our findings, our experience, and share what we usually promote in terms of resilient home construction to our low-income families. All right, so just to bring some context to the concept of building back better. The main objective of that being to make a structure, community, or nation stronger and more resilient following a hazardous or disaster event. Now, some of the main vulnerabilities, as we mentioned, hazards and disasters that we have found and it usually face the island of Trinidad or Trinidad and Tobago in general would be the uplifting of roofs during high wind events, flooding. I know for sure these two are not new to us. We also have experienced a significant amount of landslides, and Habitat usually encounters quite a lot of these issues when we offer support to our families. So these are the main vulnerabilities we have encountered, and those vulnerabilities which we have found that our low-income families are more threatened by. So some low-cost changes as we touch on the concept of building back better that go a very long way on improving the resiliency of structures. First being to reduce the risk of having your roofs blown during a high wind event. One of the first things we usually advise is that individuals maintain an ideal roof pitch of 30 degrees. It's usually between 25 to 30 degrees, 25 to 40 degrees, as you can see on the recommendation side. So that helps and goes a very long way in making the structure more resilient to the force of the wind force, as one of the presenters would have mentioned earlier. Another being along the lines of reducing the risk of uplift during high wind is to really avoid connecting, or rather avoid extending your main roof to cover carports in those areas. So as you can see in the image above, there isn't a separation between the carport roof in this illustration. It's really extending the main roof to account for that area. And what that creates is an extended overhang, which is more susceptible to the forces of the wind during a high wind event, and that can take the roof with it, as you're seeing there. So on the better side, it is to maintain the recommended overhang and maintain a separation between the roof of your main structure and have a separate roof built over any carport or any other extensions you may have to your structure. And on the illustration to the right, to the bottom right, you can see that in the event of a high wind, you're going to have the forces acting separately on that portion of that roof, and it's going to hopefully save your main roof from being affected. All right, so we find a lot of families usually build and extend their main roof, so that is something that we usually advise against. Another thing is to ensure that your connections, the connections for your structure, understanding that your structure being residential and structures in general, they can be seen as a system of interconnected pieces. And the strength and resiliency of each connecting component is very important. So in cases of a wooden structure, we highly recommend the use of hurricane straps to hold the rafters to your walls. And in this case, you would observe the rafter is secured to the wall via the hurricane strap, which is seen in green in the illustration. And then that is nailed to the wall plate. And in this case, a double wall plate that is secured by a hurricane wall strap as well. So the general rule of thumb is to ensure that you have a very strong connection to all structural members coming from your foundation all the way up to your roof. So in the illustration, you're seeing the wall plate connected via the hurricane strap, and then you have that rafter that is sitting on top of the wall plate, which is secured via the hurricane strap. This helps to prevent the force of the wind from lifting that rafter, the rafters of the roof, away from the wall. Also in view would be the purlins here, or lats, as it's usually referred to. And we have some other straps that aren't commonly used, as we have seen, aren't commonly used in structures in Trinidad and Tobago, but it's one that Habitat has begun promoting, and we're actually working with a manufacturer to kind of introduce this, and it's referred to as a purlin or a lat strap. And the intent is to connect or hold the purlin onto that rafter, so that in the event of a high wind, usually what we've found is that the roof sheeting along with the lats separate itself from the rafter, and you would find these two components would fly and be separated. So the lat strap will help to secure that lat onto the rafter in the aid of avoiding that separation. There are also some general advice in terms of the gauge of roof sheets that you should use. We generally recommend 24 to 26. We usually use 26 gauge. I know there are some higher, in this case, low in terms of high in number, but low in thickness that's available in the market. But as best standards for us, we use anything 26 gauge, between 24 to 26 gauge. That's thicker roof sheeting. All right. So the previous illustration would have been for a wooden structure, and this illustration is for a concrete structure and a steel roof. The practice that we've found across the structures that we would retrofit for low-income families is that on construction, you would usually have the block walls coming up, and in most cases, clay block walls coming up. And then we would usually find the practice of individuals extending steel bars from the ring beam, if there is one, or from the walls, if there isn't a ring beam, and the attempt to wrap the I-beam in this case, which is serving as the rafter, wrap that with 2 or 3 pieces of steel rebar. It isn't something that we recommend, and it isn't the most resilient way or the way that is advised by engineers of securing your roof system to your structure. So what we usually recommend is the use of a J-bolt, which is a J-bolt and a plate. So you have a flat plate that rests on top of the ring beam, and it's secured into the ring beam by alternating pieces of rebar, which is usually, it's called a J because of the shape. So it's alternating. This one is usually on the, for this illustration, on the left, and there's a second one just behind this one that should be angled on the right to ensure you have as much gripping power into the ring beam. So this is either bolted or in some cases welded, but bolting is usually more secure, bolted to the metal plate. And then you have a metal wedge, which is marked in the dotted lines and letter A. This metal wedge is then welded to the bottom of the I-beam. So this, in essence, is the recommended way of securing your roof to your walls, and would replace, obviously, the previous illustration, the job of the hurricane strap in this sense. Right. When it comes to fastening your roof sheeting to your, in this case, in the sense of a steel roof, it will be a Z-purlin, and for a wooden roof, it will be the lat that I referred to earlier. I don't want to believe that anyone uses the regular nails to secure their roof sheet, but the recommended thing is either a galvanized roof sheeting nail, or we prefer to use screws in all cases, either if we're doing metal roofs or if we're doing wooden roofs, because the threading on the screws help to improve the security and fastening of the screws and the sheet into the either Z-purlin or the wood, much more secure than using a nail. And in some instances, and in some islands, if the screws aren't readily available and the nails are most common, what you would find the recommendation being is to ensure the nail is long enough to go through the lat all the way to the bottom, and it's bent either left or right to kind of increase the holding force of that nail, and it would act against the wind force if there's to be a high wind event, kind of preventing that blowout and uplift that we would have alluded to earlier. So our recommendation, the screws are much better, but in the event where screws aren't available, the roofing nails are recommended. And if possible, it goes through the lat and bent to help to reinforce there a bit more. This would be an illustration of, again, that lat purlin that I mentioned earlier, in addition to the hurricane strap, but it also kind of shows the connection and the system working together. So from foundation, the intent is to build a strong connection all the way up to your roof. As you can see, foundation blocks, then you have the base plate. And this is, again, a wooden construction. You have your walls, and then you have that wall plate, which your rafter rests on. Your hurricane strap secures your rafter to your wall plate. And then you have your lat, which is secured by a lat strap. And then you have your roof sheeting that will go on top of that. If you notice here, what I mentioned earlier is that the nail comes through the lat and then it's bent. It makes a left here and it's bent in. That is if possible, that can be done. If not, we recommend screws to be used. But this illustration shows that it should be all connected and thought of as a system rather than separately. Moving on. In the cases, this is where we would kind of show an illustration from our building plan to reinforce the fact of a strong connection. You're going to have your foundation here that comes up with your starter bar, and then that ties in to your floor slab, and you continue on with your block walls, moving up. One of our main recommendations, one of the things we actually find ourselves doing quite a lot is reinforcing structures when we retrofit, or even when we replace roofs for low-income families. We oftentimes have to explain the importance of and introduce stiffeners to buildings. And it's kind of alarming how many structures are built without stiffeners. So just to give some insight, the importance of this is that the stiffeners act kind of like similar to it is really a slender or a slim column. And it really helps to support the load or helps to bear the load of the ring beam in the roof that is acting upon the walls. And it really helps to take that load off of the walls, and it can really go a long way in preventing cracking and improving the cracking of the walls and then improving the resiliency of your structure. And it also helps to hold those walls together, because we find quite a lot of structures that could have been much more resilient had they had stiffeners in place. So that's usually one of our biggest additions when we are retrofitting structures for families, especially if we're going to build a steel roof where either there was a wooden roof before, even though it's a masonry structure. We definitely include our stiffeners so that we kind of cater for the load of that steel roof on a structure that would have been aged, or that has aged. And we want to not base much reliance on the structural integrity of the blocks that were used to build the walls. So stiffener is very important. Site selection. To reduce the risk of landslides, one of the first things you can do is to ensure that, if you can, as much as possible, build on flat land. If not, selecting your site, the location for your site is very important. As you can see in this illustration, if it's a bit too close to that slope, there's a possibility of a landslide affecting your structure. And if you're a bit on top of a slope, then there's a possibility of a landslide below, taking either your entire structure or a part of your structure. And as I mentioned earlier, these are major and main vulnerabilities that we have found, and this landslide is a very, very prevalent one. And we've actually worked over the years on quite a few projects. And just to show that this isn't just an illustration, this is one of the projects we have worked on in Cedrus, where one of our families were affected by something exactly similar to this. The structure is on a sloping land, and a landslide occurred, and the structure cracked in half. And it actually took part of the building, and this is the other part of the structure. So this happened like in the middle of the night, and you can imagine how terrified that family was. Now, in cases of this, what we would have done as a solution is definitely what is required, and what we don't shortchange on is firstly understanding what would have happened. Yes, it's a landslide, but there's certain very important things that you need to investigate and know before you actually implement a solution. So we would have engaged our consulting engineers to do a geotechnical investigation to understand, yes, the land, the soil did fail, but we wanted to know at what depth did the soil fail. So they would have went out and done their borehole and their soil investigation to tell us at what depth of the land did the soil fail. So, for example, why that's important, you don't want to assume that you have a landslide and the soil has only failed where you are seeing it visibly from on top. And that can be very dangerous, because you can end up investing large amounts of money to build a retaining wall just about, let's say, 4 to 5 feet deep, but your soil has failed 10 feet or 15 feet down. So this soil investigation helps us to determine the depth of failure, the failure plane, and it helps us to know what type of soil we are contending with. And type of soil is very important when you're building a foundation or a retaining structure, because you want to ensure that you account for whether it's soft soil, whether you need to go as deep enough to ensure you're hitting bedrock and you base your foundation on that. You want to know the soil type, if it's soil that's susceptible to shrinkage or expansion. So you know exactly, and that influences your design of your structure, and again, how deep you go. So on the far right, we designed a retaining wall, very extensive retaining wall that was situated to the lower end of the land. And the intent of that wall was to brace the soil, or support the soil, because it wouldn't have been wise to build a retaining wall just below where the the soil had failed just below this mark of the slippage, because you would have still been on land that is more susceptible to sliding. So we had to go quite some distance away, kind of almost down to the bottom of that slope, build a retaining wall that would then serve the purpose of retaining the entire mass of land and support that structure a bit better. So good news, the family was able to rebuild, and now they're, and we would say now they're much more resilient. Now this could have been avoided by it may have been a bit costly, but having a geotechnical investigation done beforehand, so you know exactly what type of foundation you should have built and if you should have piled, to kind of get down below any possible failure planes to ensure your structure is secure and sturdy as possible. In cases of flooding, there's very limited recommendation currently on our side for flooding, with the exception of if you were flooded once and you're going to rebuild, we would advise don't rebuild at the same level. So or at least of the previous flood or any future anticipated floods. So in this illustration, we're seeing that the structure was flooded, and in the rebuild effort, you raise that structure. It's in 1 foot in this illustration, but the ideal thing would be to raise the structure to a level that is above the last flooding plain. If it is infeasible to do a regular flat foundation and raise it 2, 3, 4 feet, then the option is to build on columns so that you are a bit higher out of that flood line. Within Habitat, we are currently conducting a few projects and some research towards further adding to the possible low-cost solutions that we can advise our homeowners to implement to improve their resiliency. So what we are toying with, because we haven't yet had a reason to work on a structure that was severely affected by earthquakes, as much as we've had earthquakes, much of our low-income families luckily haven't. But because Habitat operates in 70 plus countries around the world, we tend to not only focus locally, but also to focus on how we can help and improve the resiliency of families, low-income families across our operating countries. So our team has taken up the task of looking at the possibility and researching in association with a few organizations and academic institutions, the possibility of introducing low-cost seismic-based isolators to improve the earthquake resiliency of our residential structures. Base isolators are usually components reserved for larger infrastructures and other major projects. If you look on most of the overpasses most of the flyovers that are done, you would observe some items similar to or identical to this. And this is a seismic-based isolator. And what it helps to do is it helps to allow it allows a structure to move with the earth when there's an earthquake. So it kind of allows that structure the flexibility of moving with the seismic load that earthquakes exert. And this can go a very, very long way in saving structures and saving lives in the event of an earthquake. The cost is currently prohibitive, and our attempt is to conduct research and innovate a low-cost way of introducing these very simple but effective components into our residential construction. In addition to that, building upon the work of Dr. Stephen Garvin from the BRE Center for Resilience, Habitat intends to promote further flood resiliency by looking into that research and considering some of these items for recommendation. Those being the installation of flood drains in buildings and sump pumps below ground to remove flood water, because we know the longer you allow flood water to sit, greater the damage can be. installation of household equipment, kitchen units, or unconcealed legs to reduce the risk of damage, and or the use of water-resistant materials in construction. For example, avoiding using MDF in building kitchen cupboards, but probably referred to using PVC boards, which is much more resilient to damage of flooding. Electrical sockets being installed above floor flood levels so that you definitely don't have to find yourself in a situation where you're forced to rewire your house or entire house, or you run the risk of electrocution during a flood incident. Tiling with waterproof adhesives and waterproof grout. That's something we're going to look at as well. And the use of flood-resistant doors and windows. Now, because we know resiliency is, it means the ability to bounce back from a hazardous event or disaster. The intention is to deposit simple and low-cost changes that will help a structure and an individual to basically minimize the amount of repairs or costs they have to incur in bouncing back or coming out from a disaster or a hazardous event. So these simple changes can go a very long way in addition to others that we will think about. And on the overall arm of habitat, we also do what is called a construction technology training. And this aims at building capacity and sharing the very information and more that I would have presented here. And it allows our builders, our contractors, and any person who's interested in construction to undergo a 6-week-long training that will give them much more information and much more in-depth information on how to build structures resiliently. We currently closed, just shortly closed our first round of training for the first part of the year. We intend on opening that training again closer to the latter part of the year. And this is the registration link. Anyone who's interested in the future can definitely register at any time. And you will have your information in the database. And whenever that comes up, we will definitely be in contact to further our work in building resiliency through capacity building. Now, we also tell our homeowners if they're affected by a disaster, or if you have doubts about your structure's resilience to a possible disaster hazard, you can definitely contact Habitat to have an assessment done. Over the past 2 years, within the past 2 years, we have kind of implemented a digital platform that would allow us to gather assessment data from the very individuals who are affected. So it's a very short, we call it a Habitat visit request form that allows us to gather information on the family, how they were affected, and simple photos that let us have an understanding of how we are to tool ourselves before we go into that hazardous or disaster environment. So any device that the individual has, whether it be a mobile phone or a laptop or a desktop computer, we would usually send this link. And as they click on it, they are presented with a form, they fill in their information, and that is logged in our database. We were able to then plan our routes and our visits to multiple sites by knowing exactly where they're located. And we can also mobilize the correct vehicle and stuff like that, given the imagery would help us to ascertain whether the access to their site is blocked and we need to use a different kind of vehicle. Or if we have any skilled volunteers in the area, we can leverage that volunteer to then do that assessment for us. But it also gives us an idea of what damage exactly the individual is facing. And we were able to then prioritize that visit and also prioritize the assistance they need, and also contact any partnering or supporting agencies that can support us on a visit depending on the scale. So that's a link that anyone who is affected by a hazard or disaster can submit a form, and we're able to assist. So that's the presentation again today from Habitat. Thank you. Definitely, if there are any questions outside of the event, we can be contacted via that number. Our website is stated above and email address there.
Thank you so much. Thank you, Jameel. This was a wonderful presentation. At this time, we will proceed on a very short lunch. So we are asking our participants to remain online. As we enter into our lunch period, we will resume at 1 p.m.
Sorry to interrupt, but we have 2 questions that needed to be answered.
Yes, let's proceed with it.
Before we go.
Yes, go right ahead, Kellan. Thank you.
All right. I'm looking at our Q&A, and the question comes from Mr. Haley Anderson. What is Habitat for Humanity's opinion on standing seam roofs and hidden fasteners?
Thank you for the question. We haven't been exposed much in terms of our construction of those of the standing seam roof and hidden fasteners. But what we do recommend, it based on what we construct, is either a gable roof at the correct pitch, or a hip roof. Our engineers have advised that a hip roof is most resilient to uplift, because it's actually secured by the 4 perimeters rather than just the 2 ends that the gable roof is supported by. So our recommendation would be inclined to go with those 2 options, because that's what we have constructed, and we usually use those types of structures for our low-income families.
All right, I think that was a great answer. Thank you very much. I see another question from Mr. Fraser. Can you comment on which construction types and material are more effective against specific natural disasters? For example, timber framing versus earthquakes and so on.
All right. I'll be mindful on my advice. I leave the technical advice to the engineers. But what I can say is, when you're using materials in structures in general, what you find, the more rigid a structure is the more vulnerable it is to disasters, particularly earthquakes. Because of the rigidity, the nature of the rigidity, it isn't flexible enough to move with the forces. And that's why for the case of the base isolator, we're looking at introducing that, because it adds that layer of, or that option of flexibility to a structure that is rigid in nature. When you asked about materials, the current masonry materials used to build masonry structure, they have been tested for years, and usually what we find isn't so much in the material that is used, but it's how that material is used. It's how it's mixed, the mixed design of the concrete, the type of cement that is used given the environment it's exposed to. So, for example, if your structure is close to the seaside where the water table is high, you may want to use a different type of cement that is suited for exposure to areas of large water table or high water table. So it's really, and what we enforce through our construction training, it's really how these materials are used and how much is used. So steel in the right portions, in the right bend, and those things. So our training kind of reinforces how to utilize the material in the best way, the properties of the material, and why they exist, and why they exist in these certain combinations. Yeah.
All right, thank you very much, Jameel. I believe Mr. Terry Ott would like to answer a question for us. Mr. Ott? Okay, I'm not, oh. I see someone asking in the chat if the link to the construction technology training can be placed in the chat for the attendees. Mr. Fraser, would that be possible?
Yeah, sure, I can make that available.
All right, thanks very much. While we're waiting for Mr. Ott, I know we have one more question. and it's with regard to what are the prospects of using converted shipping containers as low-cost housing, given their purported wind and earthquake resilience.
I'm not familiar whether the standards, as the first gentleman would have introduced, or the standards do cater for the or offer any guidance on the construction of using containers. I am aware that there are a few agencies or organizations who currently do it, or they support it. But from an organization perspective as Habitat, we have not delved into using using containers for structures. But there are definitely some considerations. For example, you would have the cost of acquiring that container. You would have the cost of ensuring that if the container had transported hazmat materials before, it needs to be cleared and disinfected to ensure it's habitable. And also, when you make cuts to the supporting or the framing of the container, you weaken the structure by making those cuts. So you may have to invest some more money into strengthening the areas you would have weakened. So we do know there's some pluses and some drawbacks to utilizing them. We haven't done so as yet. And I say as yet because we're usually open to many means of construction, ways of constructing, but it has to go through those rigorous tests to ensure, and it has to have cultural acceptance and the go ahead by the planning authorities. So to answer the question, no, we haven't as yet, but it's not something as an organization on the innovative front we would rule out, but we definitely need to have that guidance